Okay, Suresh.
Yeah. Hey, good evening, everyone, and good morning, good evening. This is Suresh. I'm the VP of Enterprise Architecture at Accion, and I led tech transformations where I modernized some of the major applications at different places. So I've already talked about domain-driven design, the first part of it. There are a lot of things that I planned in the first part to cover, more strategic portion of domain-driven design as well as tactical domain-driven design principles. But last time it was an hour session. If you have not watched that session, please do watch, because today I'm going to give a brief recap of what we covered in the last session and mostly focus on the patterns, the microservices patterns that I've implemented. I'm sure some of you have already also have experience with those patterns. So again, as I said in the last session, please chime in if you want to add anything. So today we are going to talk about orchestration pattern, choreography pattern. What are the advantages? When do you choose orchestration? When do you choose choreography, and is there a hybrid that you need to work on? Is also we can talk about it. So I'm going to use whiteboard before I start these design patterns, but quickly I wanted to share a PowerPoint. But can you all hear me fine?
Yes.
Okay. So again, as I said, I'm not going to spend a whole lot of time on the core domain-driven design because that's already covered in the first part. Just a quick recap. We talked about business domain, because before we get into domain-driven design, business domain, we talked about what is a business domain. It defines the company's main area of activity, like FedEx, UPS, courier services, Starbucks sells coffee, and Walmart, Amazon are into retail, but Amazon also have multiple business domains. We talked about that, cloud computing and retail, and Uber are ride services. Okay. When we talk about domain-driven design, we often talk about business domains, subdomains, domains. These are the definitions that we need to make sure that we are aligned on these definitions. Business domain is a much higher. It defines the company's main area of activity, and a subdomain is a fine-grained area of business activity. Like all of the company subdomains, they align with the business domain. So what are these subdomains? These subdomains have to interact with each other whenever there is some initiative. Then there are multiple subdomains that will accommodate that initiative. And there are different types of subdomains, which we talked, which is a core subdomain, generic subdomain, and a supporting subdomain. Okay. A core subdomain is what the company does differently from their competitors, which is what is their core strength. What is the company's core strength is what the core domain says. And these are some of the interesting problems that the company solves within their domain. For example, if you take Uber, ride-sharing algorithm is their core domain. Okay, mobile app is experience is a core domain, and driver management is a core domain. So you need to understand in a business domain what are the core subdomains that we are referring to. Again, at any point, if you have questions, please ask. Then we talked about generic subdomains in the last session. These are things that the problems that are already solved. We don't want to go back and then reinvent the wheel. These are the problems that are already solved. The business activities that all companies pretty much they do in the same way, like authentication, authorizing the users. You can go and sign up with an IDP and integrate for your authentication and authorization needs. And accounting, billing, still there is some integration. So, but these are more of like generic subdomains. And then supporting subdomains are something that supports your company's business. any core domains, anything that supports. These are your CRUD, create, read, update, delete type of interfaces, any ETL operations. These are the problems with obvious solutions. There's no complexity as such, but this is supporting. So basically, your core domains are the ones that are core to your organization, then the generic domains, then the supporting domains. When you're planning domain-driven design architecture, you need to plan what are my domains. First, identify the domains and see whether they are core domains, whether they are generic, whether they are supporting domains, what level of integration that we need to do, whether these are products that we buy and use out of the box or some integration is needed. Okay. And the main idea of this domain-driven design is to collaborate with subject matter experts or called domain experts, which we also talked about domain experts. They are your SMEs who know all the intricacies of the business that we are going to model and implement. Okay. They represent the business, and they are maybe the people who identified the business problem in the first place. So they are the ones who provide in-depth knowledge about the business domain so that you can visualize what is the business domain and how do you build software that aligns with the business domain. Basically, the concept of domain-driven design is you need to model your domain, build a software that aligns with your business domain, and make sure that within the context, you speak the same language and things mean the same within the context. We'll talk about bounded context in the next slide. Any questions so far? Sorry, because we already covered this one in the last session. I'm trying to go a little fast so that we'll have time to discuss the orchestration and choreography. Okay, next, the business problems. Okay, when we talk about these domain-driven designs, what is a business problem? Business problem is not always some technical problem that you need to solve. These are you're solving problems, identifying the domains, identifying the business needs, can be minimizing the manual labor or managing resources, supporting decisions, can be anything. So first, fundamental thing, you need to understand the business problem. You need to define your domains. You need to identify whether they are core domains, supporting domains, generic domains, and how they interact with each other. And then the ubiquitous language concept that we talked last time, where if you are communicating, if multiple parties are communicating, then they have to speak the same language. Yes, it's a common sense, but still, this is one of the building blocks of domain-driven design, where you need to speak the same language when you're designing, and any ambiguous terms. It can be if you are in the healthcare, you talk about policy. Okay, policy is like your insurance contract. We all sign up for insurance policies. It's an insurance contract. But when you talk about some permissions, then there is a policy. Okay, a regulatory rule that has a policy. So when you're talking, it should be pretty clear, and then it has to be within that context. When you talk about a policy, everybody has to align on the terminology. So, and also synonymous terms, which is we use subscribers, we use visitors, we use users and customers. So all pretty much in some products, they may mean the same, but you need to clearly identify within the context of what you're building, within this domain, what is a user, what is a visitor, who is a visitor, an administrator. So clearly you need to align. This happens only with collaborating with business users and understanding how they are calling this. Okay. Next is the important thing we discussed in the last session, which is modeling. Once you gather all this information, you need to model, you need to create a structure that defines what you are capturing and also what are the relationships. Okay, so this is your model. And these models fall within the bounded context, which also we discussed in the last session. Bounded context is just breaking down the whole thing, identifying the domain and what is my context. For example, customers in an online shopping, customers placing orders, products. These are different building blocks, and these are your boundaries. It's a logical boundary for you to build microservices. Okay. Then overall, a domain-driven design, now with all these terminologies, is an approach to software development that focuses on understanding and modeling the problem domain with which a software system operates. So which is modeling your software based on your understanding of the domain and collaborating with domain experts to understand different flows and how these things they communicate so that you can build an effective system. Yeah. So this is about domain-driven design. In any questions before we start talking about orchestration pattern? Okay. So let me share my whiteboard. Let me know if you can see the whiteboard. Can you all see my whiteboard?
Yes.
Okay.
Yes, we can.
Yeah. Okay. So see, normally when you are building microservices, the reason why you build microservice, the definition is independently deployable service, implement application. You can independently deploy this and scale this. But when a particular user sends a request, okay, to something. For now, let's say your set of applications that are sitting. So when a particular user sends an application request, then not always, if it is monolith, then everything is within that application, and all the retrieval process happens within that application, and then the user will get what they are asking for. It can be, you can take customer information. So getting customer information or creating a new customer, or it can be any operation. So earlier, if it is a monolith, then you just get everything together and then return that. But with microservices, you may have multiple microservices, right? You may have multiple microservices, microservice A, B, and C. For now, let's limit to 3 microservices. So whenever from the website or a mobile app, when somebody requests for something, then you may have to call multiple services to gather that information and then stitch that information together and return it. Okay. So because one microservice may not always accommodate the request, so multiple micros, you may have to call multiple microservices. When you are calling multiple microservices, one question is, how do they talk to each other? Because a user, should the user go directly and talk with the microservice, say customer information? Say customer information may have something high level, let's say a profile related information and a payment related information and notification preferences. Okay. So different types of information that you need. So these independent pieces of information. So if they are sitting in different microservices, then you have to make calls to these microservices. At times, these can be part of a single microservice, or it can be part of multiple microservices. Like say profile and notification. So if they are part of one microservice exposed as 2 different endpoints. Payment may be a separate microservice and it is exposed in a different endpoint. That case, this request that comes in has to talk to multiple services. At the same time, if it is a create type of an operation, then it has to insert something into one domain, maybe insert something in the second domain, or insert something into the same domain in a different table. So these are distributed transactions. When you have decoupled applications, then there should be a concept that should help you to at least paint some kind of picture on how these services talk to each other. So if there is a web page that has customer information, so I keyed in all the customer related information on the top, then I keyed in the address information, notification preferences, and the payment information, and I clicked submit. Okay. So when you click submit, maybe one service call that you are making, and that service call will go and save this information. But if there are multiple service calls, okay, I am adding profile, then I'm creating authorizing payment, then I'm saving my notification preferences. What happens if something fails? Okay, in the traditional type of development in the past, it is more of like it's transaction based. You open the transaction, you create one, you create the second one, you create the third one, and all three are successful, then you commit the transaction, which is pretty simple. But when you have distributed services, then every service call is separate. We also talked about databases. Microservice can have separate database, or multiple microservices can share the same database within the context of the domain. Then what patterns are available to us when we are thinking of implementing these microservices architecture? So one is orchestration. One is orchestration pattern, which we are going to talk. And then the second one is choreography. Okay. So choreography and orchestration. So within orchestration, this is more of like there will be a mediator. So when you send a request, someone is going to take the request. Someone is going to take the request, and then this person is going to go and call multiple services that are available in the background, and then they will stitch the data that is coming from all three together and then return back. Okay, so that means there is a central orchestrator. This is more of like when you see an orchestra, there is a guider, someone who is guiding all the musicians. So based on that is when if someone says, hey, play the guitar, play the drums, play the violin, trombone, then this is something that is already they practice that, they understand the flow, but someone guides them so that they only play, they know what their part is, and they do it, and they report back so that when they are done, so that then this person is going to guide the next one. Okay, we'll talk about orchestration in detail. We'll take an example, and choreography on the other side is let me see if I don't know if I shared this in the last session, but with orchestration, this is like you go to a restaurant. Okay, you go to a restaurant and place an order. When you place an order, then someone takes your order and they are responsible to go and get everything for you and give it to you. So you don't go inside the kitchen. So you don't go inside the kitchen if you want. If you ordered a combo, which comes with about 3 or 4 items, you don't know where these 3 or 5 items are, and you don't have access to kitchen also. So the mediator is the one who goes inside the kitchen and then gets everything, and then they'll put it on the table. So that way you don't know. And tomorrow, if there is any fourth or fifth item that is added to your combo, you don't need to worry about it. Mediator knows from where to get it. So that's the beauty of this orchestration. Uh, any questions so far? Or anything that you want to add based on what you have done or implemented?
So Suresh, Anand here, quick question.
Yes.
Um, can we also control what microservices a mediator can have access to depending on the use case? Or do we need separate mediators for different use cases?
Yeah,
Meaning,
good question.
yeah.
Yeah, good question, Anand. See, these mediator or orchestrator is nothing but it's a workflow, right? And you build workflows based on your use cases. It's not that there'll be only one orchestrator. There can be multiple orchestrators. And if a client, for example, somebody is creating a customer from your website, you're trying to create a customer, then there is one workflow for it. If you have a third party that is creating a customer for you, there may be a separate workflow. Internally, the building blocks are the same, which is actually your core services like a B, C, whatever we saw, A, B, C, maybe they are the same, but your workflow can be different. Let's take that example, case one, which is coming from your website. Okay, you can still see my screen, right?
Yes. Yep.
Yeah. So case one, when it is coming from the website, then there is one orchestration workflow. Okay. This orchestration workflow goes and talks to A, B, and C and returns. But the same thing your third party is trying to create, then there's a separate orchestration workflow where it is calling A, maybe only C, because B is not applicable. You don't want to capture payment information if B is payment. So there can be customized workflows for each of your use cases. It's not like a one mediator that handles everything. Did I answer your question?
Yes, you did.
Yeah. Okay. So this is orchestration. As I said, we'll talk about one example in the next slide. Then comes choreography. What is choreography? Choreography is this is more of like a group of people dancing on the stage, and there is no orchestrator. They've already they've already done all the practice. They know what to do, but on the stage, person A, based on what they did, person B is reacting. Maybe person B and C both have to react. This is where it is asynchronous. Asynchronous process is what we'll cover here. Just think about it. There are five dancers on the stage, and then person A started, and then they after they did something, then the next two people have to do something. Then the next third and fourth and fifth person has to do something. Then all five people have to do something. So this is more of like responding to what other person is doing. This is event driven. Somebody notifies saying that I am done, you take care of it. Okay. And then you are done, pass it to the third person. Or when you're done, pass it to third and fourth if needed. So this is more of like a publish and subscribe pattern. PubSub pattern is what? So this is mostly like an asynchronous event-driven pattern. Okay. But if you look at the orchestrator, what happens is I go and call A, and once I get the response from A, I go and call B. Once I get response from B, then I go call C. There is a chance of introducing asynchronous processing also, but mostly if you see orchestrator pattern, it is synchronous, right? It is synchronous, and it is again there is one single point of failure also. We'll see what advantages and disadvantages orchestration pattern has. So quickly before we go into, we have about 34 minutes, but I'm going to talk about the implementation. Okay. So normally these domain-driven microservices are implemented in more of like a layered approach. Again, if you are not able to see what I am writing, please scroll down. Okay, maybe, yeah. Okay, so let me, normally your website, makes a call. When it makes a call, it goes through some kind of a gateway. Let's say an API gateway, which is like a proxy. And then this API gateway will then pass it to your orchestrator. And this orchestrator then will go and call service A, service B, service C. Okay. But this website doesn't have any clue about A, B, C, and they don't need to even know about it. Earlier, I mean, again, I have done this few years back also, where the website will do all the aggregation. I know that I have to call these three services. I call A, I call B, I call C, I get the JSON responses back, and I'll aggregate and I'll show it on my screen. But here, this is more of like an abstraction that we are creating, where your API gateway will just say, hey, I wanted to register a customer. Okay, I want to register a customer. That's all. I'll call a resource saying register with the JSON payload, and the register request is what will go to orchestrator. And the orchestrator will say, okay, I know what to do to register a customer. So I call A, and I call B, and I call C. And once all three calls are successful, then I'm going to pass it back saying that, okay, successful register. Okay. So let's see one example. I'm going to stop sharing my whiteboard and share a slide deck. Any questions before?
So the difference is basically, I guess, the first one is the business rules or the business engine is sitting on the orchestration workflow, and it just simply calls a microservices and it does the magic within the workflow. In the second case, it doesn't do any magic. It just gets, the magic is done within A, B, and C, and it just gets everything and sends it to the calling application. Is that right?
Yeah, that is correct. See here, orchestration pattern, there is one central control that does all the processing. But if you take the same thing of registering a customer, so let's take choreography here. Your website sends a request, then maybe your A is some endpoint within the microservice A is called, then immediately there is an event that is triggered. And that event, your B will be listening to that event. Then once B is done, then again there is one more event that is triggered, and C is listening to that. And when C is done, maybe there is one more event, and finally there's some event that will send that back. So that means B has no clue about the flow at all, because I don't need to go and report to any mediator. There's no central orchestration here. All I have to do is I have to listen to this event, and when there is an event, then I have to do my portion of it and then say I am done. That way, some other downstream process is going to take it and perform another operation. So B has no clue about the overall flow. And the B should not have any clue also. This is completely event-driven and loosely coupled. But if you take a mediator or an orchestrator, there is some coupling that is involved, because you are trying to call A, B, C, and then couple them. And how are these events managed? This can be Kafka or any event broker. You can use any event broker. Again, there are pros and cons, and depending on the use case is what you choose, orchestrator or choreography. Let me show you the slide with an example, then that will make more sense. Then we can come back to whiteboard if needed. Let me share. Okay, can you see my screen?
Yes, we can.
Okay, great. So orchestration pattern. As we talked, orchestration pattern behaves like a real orchestra where there is a central guider that coordinates all the rest of musicians in order to play a symphony. In orchestration, a piece of software does that work, and by certain number of calls, it makes possible. Say in this pattern, say each service communicates directly with the orchestrator because orchestrator is responsible to return a response back to the caller, whoever is calling it. So whatever communication that happens, this communication is responded back to the mediator or orchestrator, and orchestrator will gather everything together and return back. Okay. So orchestrator component receives the workflow initiation from the client and invokes the participating microservices as needed. Okay. This central coordinator has got all the intelligence. If you look, so this person has all the intelligence on where to go, what to call, how to stitch these things together, and when to return. Okay, so let's see one example here. So in the orchestration pattern, again, we are going to take a happy path here, and then we'll also talk about what if something fails. Say this is like a Uber Eats. I want to take a pretty generic common example, the Uber Eats or any of the any application like that. So when an order is placed, an orchestrator will get this order. First thing the person does is they call order microservice. And in the order microservice, they'll first generate the order ID. Okay, someone placed an order. First, I wanted to generate an order ID. Done. Then I wanted to take the payment and then authorize their payment and process the payment. If it is for $50, something that they ordered, I created an order ID and then I also process the payment. Then I go to restaurant service to place an order because whatever restaurant that they pick, whatever item that they ordered, so I created an order for them. I processed the payment for them, and then I placed a restaurant. I placed an order. Okay. Once the restaurant confirms the order, then I will assign a driver saying that, hey, you are the one who need to go pick up this order and deliver this to the customer. Then I send the notification saying that, hey, your order, restaurant is making your order, or the driver is on his way, something like that. And then if there is any special rewards program, I wanted to also say, hey, with this order, you got 50 points. So this is a synchronous RESTful orchestration pattern where there is a request.
क्लीन मत करना बेटा, हम कर लेंगे.
Hey, if you're not talking, if you don't mind, can you please go on mute? If you have any question, please ask. Okay. So if you see here, this is a synchronous orchestration pattern where orchestrator gets a request, creates an order, processes the payment, places an order with the restaurant. If that is successful, they deliver it, and a notification is sent, and the rewards are updated. Okay. This is happy path. So what can happen here if something is not working? So what if the payment service is down? Okay. What if restaurant service could not confirm? Uber Eats, there is an order that is placed to Pizza Hut to deliver a pizza. But restaurant could not because it is close to their the time they're closing, or product is not available. So finally, they are not able to confirm the order. So what if driver is not available? Or what if the order cannot be delivered based on whatever they advertise, an hour or 2 hours? So these are different things that can happen. So in the previous slide, we only saw the happy path, which somebody gets a request and then we go through all the 6 steps and everything is good. But if something happens, then what do we do? This is more of like an unhappy path that we need to think about. So when somebody places an order, you generate the order, you process the payment. In this case, the restaurant, the place order failed. Okay, something, their service is down or they are not able to confirm. Then immediately your orchestrator knows that the restaurant could not confirm the order. Then they know what to do, because the orchestrator is intelligent enough to go and roll back this whole flow. And this is the compensation pattern, is what they call. So when you issue something, when something fails, you have to compensate to that. So immediately you need to reverse the payment. Now your delivery, your rewards, these things, they don't fire at all because your restaurant placing order failed here. So immediately you say, okay, now the payment, I need to process the refund. And also I need to send a notification saying that, hey, we are not able to process your order and your payment has been refunded. Okay. So anything like this happens, then orchestrator knows what to do. Okay. Again, this example is synchronous. Can we introduce asynchronous model here? Yes, I'm going to talk about that after I talk about choreography. But these are the things based on your workflow, you need to see what pattern is right here. Okay. But again, this is absolutely fine because your orchestrator knows what to do, and immediately the order ID is rolled back and the payment is refunded and a notification is sent, done. Okay. So now let's see what are the advantages and disadvantages of orchestration pattern. But before we talk about advantages and disadvantages, any questions on this implementation, the happy path and unhappy path of orchestrator?
So I have a question related to this mediator or orchestrator. So we are using this as a third party, or we are going to write this full logic ourselves?
Yeah, that's a good question. That again, that opens a completely different discussion. But there are third-party orchestration or orchestrators available. So, but it all depends again on your organization and your use case. The reason is this orchestrator should not have the business logic. It should only have the business flow that, hey, I need to do A, I need to do B. If B fails, I need to do C or D, something like that. But internally, the rules, the business logic, all those things stay within your actual services, right? So what I have seen is, I have seen more success in my implementations when an orchestrator is built, because orchestrator is, again, it's another microservice. It is not, it is another microservice. What you're doing is you are creating your business services and you are creating your workflow services and exposing it as a microservice, which can scale again, which can scale. But yeah, orchestrator can be a third party depending on your organization, depending on your use case. You can use a custom orchestrator, or you can build it in-house as a microservice.
So one orchestrator can call another orchestrator also?
The orchestrator is a workflow, right? One workflow internally calls set of microservices, endpoints, right? When I say set of microservices, an orchestrator internally goes and calls endpoints exposed by one microservice or multiple microservices within one domain or across multiple domains. So can you call another orchestration workflow within that? Yes, but we need to be careful with the orchestration pattern, because the more tightly coupled logic that you put, then it will become a mini monolith. Okay. Can you do it? Yes, you can. Again, it depends on your use case. But ideally, we wanted to create separate workflows. And if the second workflow need to be called inside, then see what it does and call those services so that you keep these workflows completely isolated.
Right.
Does it make sense?
Yes.
But again, the
Suresh?
biggest, yes.
Vikas here. I have another question. Suresh, I have implemented orchestration pattern on small scale. My question is that to build orchestration pattern on enterprise level, is it a lot of effort? Like, what is that pro and cons between third party and yours, building your own?
Yeah, see, again, a couple of organizations where I led the tech transformations, where I've implemented domain-driven design, we build our own orchestration layer. Okay, and the reason why we built our own orchestration layer is, in one of the organizations we used a custom orchestration tool. And when we use a custom orchestration tool, it was kind of a black box to most of the development teams on what logic they have internally in that. Because we start with some best practices saying that, hey, don't put any rules, don't put any, this is just like your workflow is what you need to have. But over a period, what happens is there are chances that you'll add more logic there. Okay, when you don't know, when you don't have control. But when you build your own workflow orchestrations, and your team who handles some of these domain microservices, they also own the workflows, and they know the clear separation of what should be in your workflow and what should be in your microservice. But again, larger scale, yes, I have implemented where they are close to about 40 to 45 microservices. They communicate with each other, different domains, no issues. And also third party, all you're doing is, I can go back to my whiteboard at the end if we have time, but even third party will call your API gateway and will request the customer information in the same way, or will register the customer information. And then you have flexibility. Say, for example, internally, you wanted to give some additional information about customer to your website.
Okay.
But for third party, you don't want to give that additional information. Then you can customize that workflow and you can build it.
Okay.
Again, both ways are again, it depends on the organization and your use case. But you can go with some product that is out of the box available, or you can build your own orchestration. I have not seen any challenge building orchestration for at least the organizations where I led this transformation. Yes, Anand?
Yeah, I just wanted to add on to that. So I've implemented an orchestration in the past. I use Pega. And when you see these larger tool sets, they also provide a business rules engine. So what happened is that in that place, all the rules were in the rules engine, and the orchestration there also started using those rules engine to actually do all the business rules, and became messy. I just wanted. So there are that you have to be very careful about that. Right? Back to your first point about keeping the rules at your microservices layer and orchestration separate from that, right?
Yep. Absolutely. See, because these tools, they come with a lot of other bells and whistles. At some point, we start using that. That's when you don't know whether you have your rules in your business services layer or whether it is in a workflow orchestration layer.
Correct. And that's what happened exactly.
Yep. Because did I answer your question?
Yes.
Quick time check. We have about 15 minutes. Let me go to the advantages and disadvantages. So again, easy to manage complex workflow and handle both happy and unhappy scenarios because one person has the central control. and easy to visualize. If somebody is looking at your workflow, they clearly know that, oh, okay, this calls order service, then it calls payment service, then it calls restaurant and rewards, whatever in the order. And with a central coordinator, it is easier to monitor and manage the interactions between the microservices. And with the central coordinator, it is easier to troubleshoot also. If something happens, you can easily troubleshoot. But what are the disadvantages? This is tightly coupled. And the more and more that you start adding, when you don't have the proper line on when to what is this this workflow, is it like a too big, or should we create a custom workflow, then you are introducing tightly coupled architecture here. And central coordinator can be a single point of failure. If your that service fails, pretty much nothing is possible. Whereas choreography pattern, there are 7 or 8 independently running services. They only go by the events. Okay, I am listening to this upstream some application, and when there is an event in my Kafka queue, then I have to do something. And once after I do that, then I have to put an event in another queue. I'm done. So if some second or a third service is down, it's not a single point of failure. Maybe your entire workflow may not happen, but still parts of it are working. So which you can recover, and you can maybe you can scale that and handle it properly. So here disadvantages are tightly coupled nature, single point of failure, and can make the system less resilient. And changing the configuration of orchestrated system can be more difficult, because if you want to change, then your workflow has to be modified. The central coordinator has to be modified. But again, there are pros and cons, guys. I'm telling you, choreography, I have implemented choreography, and there are the team has to be super mature, and you have to understand the flow. And when you have new people coming and the existing people leaving the organization, you should have a pretty good picture on how your application is behaving and working. Because with this kind of a central orchestration, you know the logic. But with choreography, over a period, there can be 100 events, and some of them are synchronous, some of them are asynchronous. So you need to have a super clear picture. Again, depending on the use case, depending on what you're doing, you can pick the pattern. And the next one is choreography pattern. Let's take, we already explained, I can go back to the slide, but let's take a same example and how it works in choreography. Oh, okay, I have to change this title of this. This is choreography pattern. When somebody places an order, the order is placed, is what an event is raised. That's it. Order placed, event is raised, and payment will be listening to this. And the payment will listen to this, and then it processes the payment, and then immediately it puts a message saying that, hey, payment is successful. I don't know what you will be doing, but my portion is done and payment is successful. And then immediately restaurant service will be listening, and okay, once the payment is successful, my job is to create an order and confirm. And once the order is confirmed, then the delivery driver has to pick up this order. And then maybe at any point, there can be multiple things happening. So until now, this is kind of synchronous, but asynchronous nature comes after the delivery. Then that event is parallelly consumed by 2 different microservices, because once the delivery driver confirms, then immediately a notification service has to send the notification, and the reward service has to say, okay, now I am going to update the rewards, or it can be anything. So this is the pub sub pattern, where you are publishing your event and multiple consumers are consuming your event. Okay, this is again a happy path. Now, same thing. what if payment service is down? What if restaurant service is down? If driver is not available? So if we don't deliver it within the time period that we advertised, then slightly it is different. Still, the concept is same. An order is placed, payment is processed, payment is success. That means payment microservice put a message in a Kafka queue topic saying that payment is successful. And restaurant service is subscribing to that topic. Then restaurant service takes it and they don't have the proper, they cannot make the order, so they cancel the order or they cannot confirm the order. Then what happens? Your payment service is also listening to restaurant service, the downstream service. And once that restaurant service puts a message in a queue, then the payment will say, okay, man, something happened. It did not go through, so I have to process the refund. And when I process the refund, after that, I have to again put a message saying that, can you notify the customer that I processed the refund? If you see these arrows, happy path is payment will go to restaurant and restaurant will go to the delivery will go to notification and the rewards. But here from restaurant, there is a message saying that order confirmation failed. Then two things happen here. This is where asynchronous thing comes into picture. So two things happen. One is I have to send notification saying order could not be processed. The second one is, hey, refund payment. And once the refund payment is done, my payment again will trigger one more message saying that notify customer. So this is choreography where one service reacts to what other service is doing. And this is completely event-driven, message-based architecture. Any questions?
What if messages are lost?
Yeah, those are some of the, the use case and the patterns. One thing is messages. If you go with Kafka topics, again, earlier it was like a RabbitMQ. Now with Kafka topics, it's more scalable. And then you take this message, you try to process this message. If you are not able to process this message, you can always handle it via a DLQ type of an option where you put it in dead letter queue.
Right.
Okay. In the dead letter queue, you can configure in a way that, hey, I wanted to try about 3-4 times. Just because if there is a network glitch or if anything, I want to try 3-4 times before something goes into dead letter queue. Okay. So you have to handle these things. The more loosely coupled that you make, then you have to also handle all these things. If something happens, if your message is not able to propagate, what happens? Who is monitoring the DLQ? DLQ can have its own, again, something is in DLQ, some other downstream application will be reading and then processing it. So that is something, it depends on your workflow. Okay?
Got it. Okay.
Advantages, choreography allows microservices to be loosely coupled, which means they can operate independently and asynchronously. Also allows microservices to be developed and maintained independently, which can make it easier to update and evolve. It's something, if you have to add one more service, then you don't have to go and update anything. All you do is, it's a chain and you put that where you wanted to put, and then you either listen to something or you publish something. But in orchestration pattern, you have to update your orchestrator. Okay? No more central choking point like orchestration service. Requests are directly handled by domain services. Okay, definitely there are advantages. Every pattern has pros and cons. What are the disadvantages? Can be complex to implement and maintain than orchestration, as it requires well-defined interfaces and coordination of interactions between the services. I have seen there was one organization where we implemented choreography. It was that the team was working on, just imagine, C#, VB.NET. they were not fully into object-oriented concepts also, but as part of modernizing, directly this was introduced, choreography pattern. Then the team got really confused because they could not visualize what these services are doing. Then we had to change that back to orchestration. Okay. So without a central coordinator, it can be more difficult to manage interactions. And choreography can make it more difficult to get the holistic view, because with orchestration pattern, you have the holistic view. But with choreography, there are a bunch of things, and you publish, somebody is consuming, listening to this queue, and if something happens, there is a DL queue, somebody else is. So it's the whole thing. Somebody has to know clearly how it is implemented. Okay. And there's no central coordinator that has the visibility. So without the central coordinator, troubleshooting can be a challenge. This is again, guys, event-driven microservices architecture is a pretty proven, powerful pattern. But again, depends on your use case, and you need to see where you are with your overall product and your modernization roadmap. And then you can either go with orchestration or go with choreography. But most of the times I have used a combination of these, because there are some use cases where you have your orchestration and some use cases where you need to go asynchronous event-driven processing. That way, tomorrow, depending on where you are and what type of, if your orchestrator is getting like too many things, and if it is becoming tightly coupled, then you can take that workflow and slowly move into asynchronous choreography pattern. Does it make sense? Questions, thoughts?
Yeah, son, just a quick thought, I guess. Yeah, you have explained it pretty well. It's like, and nowadays also, like what I've seen, that command and query separations become important, because we might be querying data from one environment, but when somebody submits a request, that goes through, as you've shown, different layers with the rules engine, some additional processing. You may not be able to give a response back right away to the user. So it's one way the user experience, we deal with it. The other end is like, we have to kind of ensure guaranteed delivery. It goes through all the layers properly, in all the microservices properly, all the environment properly. Sometimes it's like multiple systems before the actual work is complete. So that's where this pattern becomes very, very important. How you kind of separate, command and query, essentially.
Yeah, absolutely. And as I said, Sean, the combination, a hybrid type of an architecture. Say, for example, somebody is trying to register. There may be 10 things that, according to your business, there are 10 things that need to happen. Okay. But can you hold your customer when they click on submit? I know these run fast and we scale them, but still you don't want any latency. So first thing is you wanted to say that, hey, we received your request and we are processing it. Okay. That way, maybe your microservice is triggering an event saying that we received a new customer. Okay. Then whoever is listening to that new customer queue, maybe that can be an orchestrator. You know what I'm saying? That can be an orchestrator. That means you are using choreography pattern and you are also using orchestration pattern, where somebody takes that request and then internally they know that they have to call 4 or 5 things, and then they immediately respond that back to the customer, or they notify saying that, hey, your request has been successfully processed and this is your ID, please log in. Something, depending on your use case. It's possible that you can go orchestration pattern, go synchronous or asynchronous within orchestration pattern, and then also go choreography or a combination. So guys, it's 9 o'clock. I hope that this helped. And again, any questions, I'll be happy. I can stay for a few minutes and answer. Otherwise, we can talk about some other topic in the next session.
Yeah, yeah. Before I make closing marks, I will give opportunity to others. Okay, 1, 2, 3. Okay. So thanks, Hasan, for question. Maybe Suresh, that's thoughts for next session. The CQRS. What kind of patterns CQRS you have implemented and event sourcing? So thank you very much for your time. I know how busy you are. So thank you very much, and I hope we see you again on this
Yep.
forum.
This is good. Thank you. Thank you all for joining. I appreciate for taking time and joining the session. And I hope this session helped to understand some topics that you already know in more detail.
Yep. Thanks, Suresh.
Yeah.
It
Thank
can
you.
be good.
Thank you.
Thank you. Good night. Good
Thank you,
morning.
Suresh. Thank you.
Have a good one. Thank you.